Hi, hello, it is me again, Teacher Allie, Coach Allie today, actually, and I am so excited to see you. Give me a shout out in my chat if you got your post-class recap email with the awesome attachments that I put on it, because I put 3 attachments that correlated with yesterday's lesson, and I put the quiz. And I asked earlier if anyone took the quiz, and I didn't see anybody, so I'm a little worried. I want to make sure that you took the quiz for today because it's going to be important today. What was the theme of the quiz yesterday? Because it is the theme of today's class. It is the theme of today's class. Isomers! What better word is there than isomers? I am so excited. I'm glad that you got your homework. I'm glad that you took your quiz. I'm glad that you're ready to talk about some isomers today. And I'm super glad that you're here, of course, because you got to be here for any of that stuff to happen. So I'm super excited to see you. We're going to get into today's lesson pretty quickly. And I did see a really nice comment earlier. So I'm super excited to see me again. I love that. Hi, I'm super excited to see you too. But I will tell you that today I'm not teaching. Yesterday I was teaching. Today I'm not teaching. Today I'm just coaching after the lesson. And that's because this week is about showing you how awesome Kaplan is. And we're going to show you a lot of awesome. And part of the thing that makes Kaplan awesome is that we have a lot of really great teachers. And so we're going to bring in a different teacher every single day this week. The same coach, both in class and via email. Is anybody in here who sent me an email yesterday? Let me know if you're in here, because hello, it was nice working with you outside of class. I will tell y'all too that I'm very proud to say that at least as of 3 p.m. Eastern, every single email that y'all sent me about coaching, about figuring out what to do, about what date you should take your test, about specific questions from the practice test, every single one was answered. And so we're really proud of that. And I want you to continue to email me all throughout the week because I am your coach all week long. So let's get started with our agenda. Oh, you're so welcome, Lacey. You're so welcome. Thank you for shouting out. Like, I think sometimes people are nervous to email me or they think I don't mean it. I do mean it. I mean, if you got questions and they're about the MCAT, I'm your free coach from Kaplan for the week. You should take advantage of that. So for our agenda today, we're going to start with an MCAT prep timeline. Now listen, guys, I got to give you a little preview. It is going to have Kaplan materials on it. However, it's not that you can only do the things on the timeline with Kaplan materials. It's just that I'm a Kaplan coach. And so the things that I recommend for my students come from Kaplan. That's what I'm used to using. But I want you to take the big picture ideas away so that you can start thinking about what you need to have in place for your timeline. And of course, you'll see all the great things that Kaplan has to help you to do that. But I just don't want you to feel like that's your only option. It just is an option because we do kind of host all of the things anyone would ever need for MCAT. And then we're going to have our Chem Phys sample class, which I'm really excited about. And we're going to have an amazing teacher. His name is John. So teacher John is going to be here. You're going to love him. I love him. And I got to say, as nice as that comment was earlier about being happy to see the same teacher again, I gotta say, I think John's better than me. I think he's probably smarter than me. I'll put it out there. Listen, I'm not ashamed. I'm glad. I'm super happy about all of my colleagues. They're all amazing. I'm glad that you're gonna get to see a good sample of us this week. And then after his lesson, of course, we'll be coming back for plus coaching. And you know I'm doing a different coaching topic every single day. And coaching at Kaplan is not usually done in a group setting, but I can't work with you privately like I do with each and every one of my plus coaching students. But we're doing group coaching, and today's topic is going to be how to use your time efficiently on the MCAT. Let me know, is anybody afraid of the timing of the MCAT? Is anybody like, oh my gosh, it's the time, it's the timing? Is anybody brave enough to admit that? Because I'll admit it, like I was super worried about the time, especially as we talked about yesterday, because the time clicked down so that, and then I'm like, okay, how much time should I spend on that? How much time should I spend on that? So we're going to talk today about the do's and don'ts of your clock management so that you can start thinking about how much time you will spend on things, what you will do, what you won't do. And we're going to start to we're just going to unpack that. Listen, everybody's afraid of the clock. Everybody's afraid of the timer. And what we're going to do today is we're going to start to eliminate that by talking about it. And of course, again, I can't do it one-on-one, but we're going to do it in a group, and I'm super excited to do it. And if we were to do one-on-one plus coaching, then this would be something that I would work with you while attempting practice questions together so that we can make sure that you know how to do it more fully. But I think a good preview today, and I'm very excited. And then, as always, we will end with a Q&A, and I'll answer any questions that you may have. So I'm looking forward to that. So let's get started with our MCAT prep timeline. So the first thing I want to tell you is today. Any day can be your first day, any single day. Sometimes students think, oh, well, what is the average amount of time that someone prepares for a January test or a March test in May? You know what? Any day can be day one. And I tell students this all the time because what is average is average. That doesn't mean it's what you need. It doesn't mean it's right for you. And you will never be mad at yourself for starting early and getting more points than you expected to get. But let me ask you this. Will you be mad at yourself if you accidentally started too late and you can't go to the test date you wanted? Are you going to be upset about that? Because I think so. Because I think no one is ever going to be upset about starting early. No one is going to worry about that. Because if you reach your goal early, guess what? That's just more points and more points than you even expected. And you cannot possibly go wrong with that. But you can, and sometimes students do, wait too late to start. So any day can be day one, and I want you to make it day one for yourself as soon as possible. And I mean with comprehensive prep. I don't mean with, the MCAT free prep week is great from Kaplan. I love it, but it's not going to be enough to get you all the way. So start adding in all of those other things that you're going to need. And then as you're prepping, right? So during your MCAT prep course or as you're prepping, you need to worry also about strategies. So yesterday's lesson and all of the handouts that I sent were very much about strategy. You guys know that I'm a big fan of strategy, about utilizing those patterns on the test. If you remember, you can feel free to shout out that hashtag of mine. But I want you to remember what you are and what you are not. So you've got to study your strategies. And in fact, one of our lessons this week for coaching is going to be about the balance between content, how you can study content, strategies, how you can study strategies, and the blending of the two so that you can kind of figure out how much of a proportion of this you need and how you can study it and what proportion of this and that. So that you can look forward to later in the week. But you've got to make sure that you aren't studying content that you already know. Just because you miss a question of a certain type doesn't mean that you don't know that science. It could be that you got tricked by a certain type of wrong answer that they put in there. It could be that you fell for, we saw yesterday, a common calculation error. And remember every single thing they do. Remember when they use the word respectively? Every single thing they do is meant to trick somebody, right? They think, okay, a certain percentage will fall for this. A certain percentage will fall for this. A certain percentage will fall for that. So you need to make sure that when you miss a question that you figure out, is that a content issue? Is that me falling for one of their traps issues? Is that a timing issue? Am I rushing? You got to know exactly why you're missing something. So as you prep, really think about that balance between strategy, test taking, and content. Because I tell you what, I've seen many students come to me, and when they come to me, they've been studying a long time, and they're like, I feel like I know this science. Is there anyone brave enough to admit that? I'll admit that I thought that I knew what I needed to know for the test, and yet even still, even though I knew, or if you have friends that you know are super good at science and they didn't make it, I felt like I know science. Why am I not getting the score I want on the MCAT? And that's why, because I just kept with the content review. It wasn't until I got realistic practice and I was able to understand and break down. Thank you for being brave. I know, listen, the reason I ask y'all to be brave is because I want you to know, and I want your friends in the room to know, that you're not alone. You might be prepping alone outside of here, but inside of this room, you are not alone. You have a whole support system around you, including your friends who are going through the same thing. And so that was my thing, and it's not everyone's thing. Some people are great at tests and it's a content issue. Some people have a little bit of all the issues, and so you got to figure out what it is that is messing you up. And one of the things that I think can really help with that, and it is actually the remediation process of Yale Medical, is that they have to, when they do poorly on a test, they have to go back and explain everything that they did wrong and why they got the question wrong so that it doesn't happen next time. And that's something that I think is great to start putting into practice right now. Really ask yourself. And of course, a plus coach would kind of help you do that for you if you were Kaplan students, but you can do it on your own. Make a list. This is why I got it wrong. This is why I think I got this wrong. This is to combine these two things. And then look for patterns, and you're going to see what you can do to improve. But you got to know why you're missing stuff. And I promise you, it's not just content, because many of you are great at science and you don't have the score you need. Many of you have probably already mastered all the science you need. And one of the things I like to tell people always tell me when I first meet them, they'll get over it. But when they first meet me, they'll say, it's such a hard science test. The science is so hard. And I mean, yeah, it's not easy, but you guys have studied this before. And I've looked at your GPAs because you've told me for the last 2 classes in a row. So I know that you know this stuff. What you need to understand about the content on the MCAT is that it is a mile wide, but it's only an inch deep. Like, they need you to know a little bit about a lot of stuff, but they don't expect you to know a lot about certain things. You got to think about MCAT testable content, right? You know that there's a lot of things on the MCAT, but what is testable, right? What's testable is only what they've said they're testing you on. First semester concepts for the most part. So again, mile wide, inch deep. Don't get too hung up on content that you can't move forward. But as you're coming towards test day, you need to really become very realistic in your practice and your prep. In that home stretch time, you need to be taking a lot of practice tests. One of y'all asked me yesterday how often, and I said there will come a time in your prep when I'm going to tell you once a week. And when you're in the home stretch, that is the time when I tell you at least once a week. And that's for a full-length test. That's a full-length test. And sometimes people ask me, well, Coach Allie, how many tests should I take? And I say 6. You should take at least 6 full-length tests before you get to test day. And one of the reasons I talked about a little bit yesterday, and that's because if you see on one test that you have super strengths on this type of question and not on this type of question inside of a section, that doesn't necessarily remain static. So if the thing that you're not super great at in that section, they don't test as much, or when they test it, they give the easier questions, and your strengths, they ask you harder questions there, you're going to do a little better. But the next time you take that test, if they pick the thing that you're not so great at to make the hardest type of questions, or they test it just a little bit more, all of a sudden your score isn't exactly the same as it was. And you're going to be like, why? And it's because maybe you're studying just your strengths or just your weaknesses. You can't do that. You guys study a little bit of everything. And so I like to see my students have at least 3 practice tests in a score range that they are comfortable with applying, to be for sure that they know that they can get that score and that those strengths are real. That's what I want to see from y'all. So make sure that throughout your time that you're practicing, that in the home stretch, you really get realistic. It should be timed, it should be full length, and it should be on AAMC material as well as much as possible. And I will tell you that Kaplan courses do include every single thing that AAMC has released, including their most recent full-length test. So all 3 of the full-length tests and all of their question packs, every single thing. And we add that. So for our current Kaplan students, when the test wasn't out, the 3rd test wasn't out, it wasn't in their course. But as soon as the 3rd test came out, we migrated into their course. Never have to get anything else. But I really want you to do realistic practice on the real tests as well, and their question packs as well. I find that to be very important. And I find it important especially for our Kaplan students, just because I always say that if someone teaches you a method, but they don't show you how it works on an AAMC question, I don't believe in that method, right? So I like that Kaplan includes all that stuff, because I can confidently say everything we teach absolutely works on the real stuff. And actually, we've got all the real stuff. Let's go and show you right now. So make sure that you do that whenever you can. And Robbie, your home stretch is really going to depend on a couple of factors. It's going to depend on how long you've set aside to prep, just at all. And it's also going to depend on where you are in your prep process, because your home stretch might be a little different for some people, because if you're still trying to master content, it's not time to be taking full-length times tests. It may be time to think about maybe we change our test date. That needs to be a conversation that you have with yourself kind of early. But if you want, you can email me all week long. I am your coach, totally free from Kaplan. If you want to tell me a little bit about your situation when you're testing, what else is going on in your life, we can kind of figure out what your timeline should look like. And I'll be happy to do that. And, you know, my email is up top on your screen. Jennifer, you become a Kaplan student by calling 1-800-KAP-TEST. And if you want a plus coach, you can request Coach Allie, because, you know, I'm there. Or any of the teachers that you see this week, you can figure out how to get in their classes, because we are all real Kaplan teachers and we'd love to see you in our full class. But that's what I have for you today, leading into our conversation, our Chem Phys class. I'm super excited. I hope that those analogies that I sent you last night will help you in today's class. You know, I love a good analogy. I love a good analogy. So I hope you enjoy that too. I'm going to pass you off now. I'm going to pass you off to your teacher, John. I can't wait to see you afterwards for coaching. Remember, we're going to talk about the do's and don'ts of clock management. I'll see you then. Bye-bye.
Awesome. Thanks, Allie. Appreciate it very much. And hello, everybody. Welcome to your science portion of today's class. And so we're actually going to switch over to our slides real quick here. Now you might notice a little spinning wheel that will go on for a second there, and then it should appear a high-yield science stereoisomers. And one thing we like to do a lot in our classes is we do thumbs up with the number 6. I bet Allie's already done that at one point. So just give us a thumbs up in the chat there if you can see the slides, and let us know that you can see the stereoisomers that has appeared there. And so as you can guess, we're going to spend a long time talking, well, not a long time, but a good amount of time talking about stereoisomers, and most importantly, how they show up in the context of the MCAT as well. Cool, and there we see a bunch of different answers. Perfect. All right, fantastic. Thanks, everybody. So welcome. This should be fun. So what we'll do is we're going to do a review of all the things you talk about in your standard organic chemistry classes in terms of stereoisomers. But as we said as well, we're also going to try to connect it to some higher difficulty, I guess you could say, science concepts. And so can you think of anything beyond just standard organic chemistry where you could see stereoisomers show up? So not just the standard, like nomenclature questions and questions on whether some things are or S, but maybe on something a bit more difficult in terms of topic areas. I know there's quite a few that do show up on the MCAT. It's kind of like combinations of organic chemistry and other types of science. And the number one, as you can see everyone saying as well, biochemistry. Biochemistry is one of the, I would say, most ubiquitous topics that does show up on the MCAT. And so we're going to spend a long time kind of breaking down on both reaction chemistry and synthesis, as you guys are saying as well. But yeah, exactly, as Sally's saying, your old nemesis, which hopefully biochemistry will become one of your best friends by the time you're done with your prep. But it does take quite a long time. And so actually a little bit of information that people aren't always aware of is that when it comes to biochem on the MCAT, there's actually equal amounts of biochemistry in the Chem Phys section as there is in the biochem section. And so what the AMC often does is they're not going to just give you standard questions on things such as Krishna's saying the citric acid cycle or amino acids, as Joey's saying. Yes, they are going to ask you about these things, but what they'll often do is try to blur the lines. They'll give you questions on physics, but you're going to have to use your background knowledge of organic chemistry or biochemistry to try to figure out how they actually relate. And so we'll try to do the same thing today. We'll connect some dots, show how everything is very related, and we'll do so in the context of 3 main classes of isomers: constitutional, conformational, and configurational isomers. And then, of course, we'll get into double bonds, and then enantiomers, diastereomers, and we'll even use the context of an actual thing from medicine to do so. And so as you can see, we've got a little passage here. And as you know, the MCAT's also a passage-based test. So you don't just get discrete questions, you get lots of questions based on prompts like this. And so we're actually gonna, I'm gonna jump off camera. We're gonna give you a minute, read through this. It's gonna go through a bunch of different things on, as you can see, ibuprofen. And then we're gonna go through a series of questions, not just to answer this. And I bet a lot of folks can probably answer the question right away here. But that's not the point. What we want to do is get deeper into the concepts that are required to confidently solve this question and then go through them together as a team. So I'll hop off, give you guys a minute to read this, then we'll come back and actually discuss all of the different ideas behind it. All right, so we gave you a little bit of extra time there. There it is. Perfect. So, how did that go? Interesting. Maybe we've seen this before. Maybe we haven't. This is a pretty good example of the kind of stuff that you can see on test day. No, looks good. Perfect. Cool. Thanks, guys. All right, so as you can see, this is a passage about ibuprofen, and it looks like we've got two different isomers that have different side effects. And so one has a different effect than the other, and it turns out that there's this isomerase that can actually convert one to the other. And so enzymes are a really big part of what you're going to see on biochem, and so we'll go through what that means when something requires an enzyme to actually convert back and forth between the different forms here. All right, so as we said, we're just going to use this as an opportunity to dig into a bunch of different forms of isomerism, and then we'll try to figure out what kinds of isomers, or specifically what kinds of isomers we must have between these two forms of ibuprofen. Cool. All right, so first we're going to look at conformational isomers, and so here's a question for you all. When you see these conformational isomers, what kind of bond are they differing across? And that's, as you can see, I just put a box around them right there. And so we're trying to figure out how these things are changing and what the different arrangement is around them. And these are known as Newman projections. And just to give everyone a sense of what these look like, this is looking down a carbon-carbon bond. And so that little triangle I just drew, kind of like a Mercedes symbol, that's representing the very first carbon. And then right behind that, we've got this big circle, and the big circle represents the carbon that's directly behind that. And so we are looking across a carbon-carbon bond. I don't know if that's a single bond or a double bond, because notice what's happening here is that it's actually freely rotating back and forth. Notice the only difference here is that the one on the left, everything's more spaced apart, and then the one on the right here, everything's quite a bit closer together. And so, as you can see, the one on the left is more stable. This is also known as the anti-conformation. Nice and exactly. Yeah, Eva's got it. So it's single bond. It's a sigma bond, of course, are your single bonds. And the one on the left here is known as an anti-configuration. The one on the right would be considered gauche. I'll label those on the screen right there. And so what we want to do now is go through all of these different questions and figure out, of course, what kinds of isomers we have. And as everybody's saying there, this is just a single bond. We're rotating around it. It doesn't require any breaking. You can just rotate back and forth between these two forms without having to break anything at all. Also, nice, Ali. They do have the same connectivity as well. In fact, here's the shortcut when it comes to conformational isomers, excuse me, as we have here on the left. These are actually the same molecule. They're the same thing. It's just that it's rotating around this sigma bond, and so it's kind of the same molecule at different moments in time. All right, so that's a conformational isomer. We have different configurations. There's anti, there's gauche, there's eclipsed, and of course there's staggered, as we can see here as well on the left. So that's your anti-staggered, specifically conformation there. All right, so that's conformational. Let's move into the next ones, and the next one here is configurational isomers. Now, we've got some, I bet we have some biochem pros in the room here, and so I'm curious if anyone recognizes how this molecule fits into the larger picture of metabolism. It's actually missing a phosphate group, but other than that, it's actually really similar to something that we do see in metabolism, of course, which is a big part of biochemistry. And let us know if you know where this fits into the system of metabolism. If anyone's good at their biochem, they might recognize it. And if not, we could probably figure it out. Nice, it is glycolysis. It's an intermediate of glycolysis specifically. Actually, Denise has a great question of glycerol. I actually want to show a little structure of glycerol real quick. And so glycerol is a 3-carbon, nice, Mariah's got it. It is G3P if we added a phosphate on. Very good work. And actually, Joey's got a great question too. I will talk about that because I realized that when we said that, it's kind of hard to see because we don't actually have anything fully eclipsed. And I'm going to relabel this just so it's a bit easier to see definitively. So I will go back to that 1 second. But first, let's talk about glycerol for a sec here. So this is glycerol. This is a 3-carbon alcohol. It's how we store our triacylglycerides. You see that often broken down as G3P. And so in this context, what's the highest priority group in this glycerol here? So like, remember, when we think of our nomenclature, the highest priority group is the end of the name. And since it's glycerol, that means the highest priority group must be an alcohol. That's why it's glycerol. But notice the next one here, you actually got a different highest priority group. And so what's the highest priority group in this, what we have here? Now, we saw some folks in the chat actually said that was G3P. That is totally true. Actually, Ava's got the full name there. Notice that we've now increased the oxidation state. So it's more oxidized than the alcohol, as everyone said for glycerol. This is actually glyceraldehyde. And so this is glyceraldehyde. Nice, everybody. It is one of the intermediates in glycolysis. And notice that the names here, it's the same thing. If you just oxidize glycerol a little bit into glyceraldehyde, you can figure out the names of this thing, because the only difference is that highest priority group. It's just the aldehyde there. And so this is actually glyceraldehyde. In order to completely have this be part of your, intermediate of glycolysis, it would be G3P. That stands for glyceraldehyde 3-phosphate. So all you'd have to do is pop a phosphate group nice onto the end of the structure here. And so one of the things that you're going to realize as you do more and more of your MCAT prep, it's not that you need to memorize the structure of G3P, glyceraldehyde 3-phosphate. Instead, it's understanding the rules that govern nomenclature and being familiar with a bunch of structures that show up a lot. So, thanks, Allie. And so here's the whole idea is that you already know glycerol. And if you know glycerol, you can infer the structure of glyceraldehyde. And if you know what a phosphate group looks like, which you need to, you can then quickly infer what G3P is relating to glyceraldehyde. And so that's our number one recommendation for everybody here today. It's not memorizing a bunch of stuff. As Ali said before, it's understanding how things relate. It's seeing the structures and trends that exist within all these terms and being familiar with the rules enough to be able to know what the structure actually is. And so this is glyceraldehyde. Now, we'll jump back to the actual thing here about bond breaking. Let us know, does it require bond breaking to convert between these two different configurational isomers now? Cool. All right, so notice if you look here, and I'll show you the difference, these are known as Fisher projections. And Fisher projections imply that any group going side to side are coming out of the page. Any groups going up and down are going into and out of the page. Sorry, into the page, excuse me. So side to side's coming out, up and down's going in, and these are known as Fisher projections. And yeah, exactly, Christina, Chevalique, I think that's the correct way to pronounce that. You guys are totally right. It will require some bond breaking to convert between these two. Notice that we have different arrangements of those alcohols. You can't switch between one and the other. All right, so true. All right, and so exactly this is actually two different forms between the two. All right, does require bond breaking, as you can see. And notice if you look at the actual different substituents here, it's still the same connectivity. And the reason that we say it has the same connectivity, notice on carbon number 1, they both have an aldehyde. Carbon number 2, they both have an OH group, right? A hydroxyl group, a hydroxy group, right? Alcohol. And on carbon number 3, they both also have a hydroxy group. So you'll notice that these two are the same structures, they're just arranged a little differently in space, much as your hands. Cool. Oh, gotcha. All right, cool. So yeah, exactly. It's kind of like two non-superimposable mirror images. That. Cool, thanks, Allie. And so these are, in fact, does anyone know what types of isomers these are as they're shown? Notice that you've got a single chiral center. And as we said, I guess we didn't mention this before, but nice, Sawa, these are enantiomers, really good work. So enantiomers, and we'll give you the full definition here since they're shown on the screen. Enantiomers, we'll give you the definition, enantiomers are two compounds with the same connectivity with completely opposite chiral centers. And so I keep using this word chiral centers. What makes something a chiral center? So what makes something a chiral center as well? And as you can see, these are enantiomers, two compounds with the exact same connectivity, just different chiral centers. And that, of course, is, nice work, anytime that you have a single atom with 4 different groups bound to it. Oh, thanks also, Greg. Perfect. Put that down there. Perfect. Yeah, so it's asymmetrical. Now, to get some big ideas here, let's kind of connect to not just chemistry, because we really only talk about chiral compounds in the context of organic chemistry. We got 4 different groups bound to the same carbon, but this is something that applies to things in the real world as well. So to give an example, your hands, and I know everybody does this in orgo classes, so we'll do it too, but your hands are really good examples of chiral compounds. The reason that your hands are considered chiral is because they look different from every perspective. The front of your hand looks different than the fingertips, than like the wrist side, the back of your hand. No matter what angle you look at it, it looks different. That's what chiral things have. They call it handedness. In fact, chiral is even the Greek word for handedness. But certain objects don't have chiralness. They aren't chiral. They don't have handedness. Like a pen's a good example. While the tip looks a lot different than the back of it, it looks the same no matter what perspective you look at it along the sides. Thus, it's an achiral object. So just be aware, chirality, yes, we use it to describe molecules, but it's a larger idea than that. It's something that extends to objects in general. It's just that to apply it to the context of chemistry, we are, as you're saying, 4 different bonds bound to the same essential atom. Nice work. All right, cool. So that's chirality in general. Yes, this is chiral because, as you can see, this chiral center with the box around it has 4 different groups bound to the same central carbon. All right. So our next example here is constitutional. And so constitutional isomers actually has another name. If anyone happens to remember what the other name for constitutional isomers is, please throw that into the chat as well. But notice the big difference here is that the one on the left is still glyceraldehyde. Same thing that we have right there to the left of it. But the one on the right is different. In fact, what's the highest priority group of this compound on the right here? And nice, Julia's got the right answer, first one to say so. Constitutional is also known as structural isomers. And so I'll put AKA, also known as structural isomers as well. Nice work, Alex, and everybody. Cool. So that's your constitutional isomers. And so yeah, looking here, notice the one on the right. It's no longer an aldehyde. What's your newest highest priority group there, as we said, on the right-hand structure there? And we can actually do the same thing. You'll notice it's very similar to something else. Nice, it is a ketone. And so what I drew here was the most basic ketone, and I bet you all recognize it as acetone. So notice what we have here is an example of an acetone molecule, but it has a hydroxy group bound in every possible position. This is another intermediate of glycolysis, dihydroxyacetone, because as you know the structure of acetone, at least we hope you know the structure of acetone. If not, you got to know it. Basically, all you got to do is put 2 hydroxy groups on it. Yeah, exactly. And so just be aware, all of the examples that they tend to give you on test day aren't just random examples you'd see in an orgo class. They often relate to biochemistry, glycolysis, Krebs cycle, some other larger structure. But what they're doing here is they are testing, of course, on just the basic isomerism, but then they're going to use examples from your biochem. And so the more biochem you know, the easier it's going to be. Gotcha, cool, and thanks. Perfect. All right, so as you can see, to switch from an aldehyde to a ketone, this is definitely going to require some bond breaking to switch between the two. And the other big difference here, as you can see, is that these no longer have the same functional groups. And since they no longer have the same functional groups, that means they're going to have different names. And so we mentioned this before, but I just want to recap. Remember, in the rules of nomenclature, we name things according to their priorities. and we said their priorities were based on how oxidized they were. And so notice if you ever change what your most oxidized group is, you're going to change the name of the compound. And so anytime you have structural or constitutional isomers, they have different names because they have different functional groups, they have different connectivity. All right, awesome. Perfect. All right, so let's break down the question at the very top of the page here. And notice at the very top of the page, the general theme as you work your way to the right. So notice the left-hand side, we have conformational, then we have configurational, and then we have constitutional. As you go to the right, remember the left ones, these were the same compounds, right? They're just differing around a single bond. But as you work your way to the right, then you get different isomerism, and then you get completely different compounds. They're getting more different as you go to the right. Thus, you're decreasing similarity as you go to the right across the page. All right, so now let's do one more thing before we move on, but we'll start breaking this down even further. But I want to return to what we said before about conformational isomers, because I realize these are drawn in such a way that it's kind of hard to see. And so I'm going to actually change this to be very specific, because it kind of depends on what you're looking at here. But so to be more specific, the one on the left here is known as staggered. Staggered's a broad category that anti and gauche fit in alike. The one on the right here, let's say, just to be real specific here, that these groups, like that COH group, is actually right on top of that OH group. So if these were directly on top of each other, which we're going to say they are because they're drawn a little ambiguously, but if they were meant to be that, then it's known as eclipsed. And so I'm going to define these as staggered and eclipsed, just to be a bit more exact. And so remember with eclipsed, that means if they are actually right on top of each other, right? So they're actually eclipsing, just like happens with Hearts, with that really cheesy 80s song. I don't know if you remember that song, Total Eclipse of the Heart. Became very popular during the solar eclipse this year. But if you've never seen that music video, after class today, I encourage watching it if you want to be a little freaked out, because it's probably one of the weirdest videos that you'll ever see in your life. And it's a nice way to remember, of course, eclipse conformations, just because it is so weird. But yeah, exactly, Aishwarya. It's probably the strangest video you'll ever see. All right, so there's just to be a bit more specific about staggered and eclipsed conformation. Gauche means that you get your groups close together, so they're awkward, and then anti is when they're far apart as possible. I just wanted to basically be very specific with the differences there. Cool. Yeah, it's a great song. Weird video. Super weird video. All right, so let's break this down further. Let's talk about the different forms and try to figure out what we can actually eliminate. Because what we want to do in this prompt, right, was we want to figure out which of these is not going to work. And so are there any, and actually, I believe we have a poll here. So before we even get a bit further, are there any types that we can eliminate in terms of conformational versus configurational versus constitutional? Let me know if, let me check that. Cool, there we go. So let us know in that poll, which of these can we definitely eliminate, given what we've talked about ibuprofen? Yep, cool. Thanks, Allie. All right, so we're going to pull up in 1 second here. And so just let us know. Given these couple options, are there any that we can definitely eliminate since we know about ibuprofen? I'll jump back to say a couple things about ibuprofen real quick here. Cool. Thanks, Allie. Appreciate it. Perfect. All right, so I'm going to go for the we'll go for the highest voted right now. And so the highest vote we have is actually for conformational. And I agree that they can't be conformational isomers. As well as our second vote, nice work, we have constitutional. And so really good work. We've got more than half the class going for both conformational and constitutional. And so let's figure out why that's the case. So what was it that let you eliminate conformational isomers? This is kind of a more complicated question. Remember, we said conformational isomers. These were the ones that were rotating around a sigma bond, right? So it's kind of the same molecule, It's just at different moments in time. So why did you all know that it wasn't these conformational isomers when we talked about the different isomers of ibuprofen? Interesting. We got most of the class going for that. Definitely not conformational. There's a couple big differences that we learned from that prompt about the different forms of ibuprofen. And one of the biggest differences that it said was while they can interconvert, there was one necessary piece in order for these things to convert back and forth between each other. They don't just freely rotate, it's that it required an enzyme. Specifically, we need an isomerase. And also, previously in the chat, I saw someone bring up mutase. Mutase is a type of isomerase. And so, basically mutase, isomerase, same idea. And exactly as people are saying there, as you can see in the chat, it requires basically, bond breaking to switch between these two. You need an enzyme to actually do it. And since conformational did not require bond breaking, as well as Kenzie's saying, one's biologically active, the other is different, they have different chemical properties, and it requires bonds to convert back and forth between the differences here. But nice work. Yeah, so it requires an isomerase, and for the MCAT, you can call mutases isomerases the same thing. A mutase is just a type of isomerase. All right, so our second one was, why isn't it constitutional? We had most people eliminating that one as well. And so let's cross these out as we go through. And so we said before about constitutional isomers, or when you had the examples were something such as we had glyceraldehyde, and we compared that to dihydroxyacetone, right? Which we could just use the word roots there to figure out the differences between those. And in this case, they're not quite that different. Because if we think of the different types of ibuprofen, notice we're still calling them both ibuprofen, Lacey. Exactly true. They still have the same connectivity. They still have the same name. And if they have the same name, they can't be constitutional isomers. You got it. Those would have completely different names. You'd have like an aldehyde versus a ketone versus something else. You got it. Nice work. Yeah, so perfect. Yeah, definitely not constitutional since they have the same name. Perfect. All right, so now we can break it down. We do know their configuration, but configurational has a couple of different categories. As you can see, they can either be cis-trans, they can be enantiomers, and they can be diastereomers. And so, Allie, if you don't mind, let's actually grab that other poll, the second one that kind of breaks down the differences between optical, enantiomers, diastereomers, and we'll throw that up as well. And we'll just let people vote on that real quick. Perfect, thank you so much. Awesome. Perfect. Sweet. Thanks for the results, Allie. So it looks like we've got most of us eliminating cis and trans isomers. I agree. These are definitely not cis-trans isomers. In fact, when do you usually even see cis-trans isomers in the context of the real world? Like actual life, whether it's biochemistry or food, or like more than just, the classes that you have in college, of course, because cis-trans is pretty common. And nice, Breeze is bringing up the reason why. We don't have any double bonds in this structure, and since we don't have any double bonds in this structure, we know that there can't be differences in cis-trans isomers here. And in terms of where we usually do see cis and trans, is everyone's favorite kind of food, as Alyssa's saying, it's in fats, fatty acids specifically. And so I do want to bring up a little bit of life advice, since we're going to talk about cis and trans fats. And as Sam was bringing up, trans is the big one to talk about. Trans fats are incredibly unhealthy for you. In fact, they're so bad for you, and there is so much research-based scientific evidence out there at how unhealthy trans fats are, is that the FDA is in the process of making it illegal to cook with trans fats in America. Not just in the state of New York, or New York City passed that law a little while ago, but they're actually in the process of trying to completely remove them from the food systems of America. And here's one of the reasons why. If you've got a trans fat, and as you can see, trans is when you have your groups on the same side. If you've got a giant long chain fat with some trans bonds in it, those trans bonds are going to stack very well. And if you get a bunch of fats that stack together very well, they're going to conglomerate. And if you get a bunch of fat that's conglomerating together, it's going to cause plaques, which can cause heart disease, strokes, lots of other things as well. And additionally, this is another reason why it's really bad. Not only is it going to form claques and plaques, which happens with other types of fat too, but trans fats don't exist naturally. Like, they're made by scientists in the food system because they don't exist in nature, so that means that we don't have the enzymes to break them down. That's why they first thought that trans fats were healthier, because there's no caloric value because we can't digest them. But the problem is, if you can't digest it and it's fatty, it just gets stuck in places and bioaccumulates, which of course causes lots and lots of problems. That's why if you ever do see trans fat, often it's in those foods that can sit on the shelf at the gas station for a year and not rot, because it's basically increases the shelf life of something. But the thing is, it's not just going to increase the shelf life on the shelf, it's also going to increase it in your body. You can't break it down, which causes lots of problems. And so trans fats are horrible. I get off my soapbox, avoid eating them. But thank heavens within the next couple of years, they're going to be removed from the system. But yeah, there's lots of other options like olive oil, coconut oil, ghee. You've got lots of options. But yeah, exactly. Just try to avoid anything that has any amounts of trans fat. That's my advice for today. All right, so as you can see here, when we look at the structure of ibuprofen, there are no double bonds that differ in cis-trans. Yes, there's a benzene ring, but you can't have a cis-trans benzene ring. That's not a thing, right? And of course, if you look at this, what's this functional group there as well for everybody? So notice we've got another double bond in a functional group on the far left. It's one of the most oxidized functional groups that you will see ever in organic chemistry. And as you can see in the chat there, it is an example of a carboxylic acid. There we go. Yeah, carboxylic acid, as you guys are saying. So we've got a carboxylic acid. Yes, it also has a double bond, but notice this double bond, there's no two groups on one side. We've got a carbonyl. There's not enough substituents for this to be cis or trans either. And you really do, as we said before, you really mostly just see cis and trans in the context of fats. That's the most common way that you're going to see that in the real world, or IRL, as people say these days. All right, so there we go. We know it's not cis or trans, and also looking at the polls, we had more of us eliminating diastereomers and not enantiomers. So as you can see, it is in fact enantiomers. So there's a really strong requirement. In order to have diastereomers, what must be true? Like, not any compound can have diastereomers of each other. It needs to be a specific type of compound in order for them to actually have diastereomers. And we'll give you the definition here. But as we said before, when we talk about enantiomers, enantiomers are whenever you have every single chiral center opposite. Diastereomers, on the other hand, require a bit of a mix, where you've got multiple chiral centers, but those chiral centers, nice work everybody, have to be, of course, different arrangements. And so let me give the definitions down here as well. And so we already had in the chat when we talked about enantiomers, but so diastereomers are when you have multiple chiral centers. Nice work. Chiral centers, where some are the same and some are different. One of your most common places that you're going to see diastereomers in biochemistry and the MCAT in general is in the context of carbohydrates, sugars. And so you'll see a bunch of different diastereomers of things like glucose, mannose, galactose. There's a bunch. And yes, you do need to know the structures of very common sugars, as well as be able to look at the ring form of a sugar or the straight chain form of a sugar and be able to figure out what it is. Now, that's some really hard biochem for a lot of us, but this is the kind of stuff that you're going to see on test day. And so if you know how to not just memorize the different structures, but how to look at one and figure out what it would look like in a ring versus as a chain, that's going to be a really important skill for test day. But actually, I will mention one more thing, though, since we're talking about these. But what's even more important than sugars is amino acids. And I know folks brought this up earlier in class, but you gotta know your amino acids for the MCAT. If there is one thing that you just gotta memorize for test day, right at the top of that list, I would put in amino acids, including their 3- and 1-letter codes. And so I'm assuming if you've ever had a biochem class before, you've had to memorize them. And the nice thing is, remember, this is a multiple choice test, so you need to draw them out, but you do need to recognize them and be able to name them when you see them. And so that's going to be one of your really important, just, straight up content that needs to be known for testing. Yeah, exactly, as Gary's saying, you got to be an expert. Oh my gosh. Oh, yeah, all right, that's a great one. I would love to spell out names with, I guess not everybody can do that, though. It depends what your name is. There isn't a J one that I can think of, so that wouldn't quite work, but I guess a lot of folks can. Yeah, exactly. Yeah, and oh my gosh, as I swear I was saying, so important to know the category. Yeah, know the categories, right? So which are aromatic, which are basic, which are acidic. Know what kind of a charge they would have at certain types of pHs. Like, that's how much you got to know these things. It's really important. All right, so let's do one more thing, and folks already brought this up in the chat previously too, about the differences in biological activity. And so one is biologically active, the other one is not biologically active. And it's so important in pharmacology to know that different enantiomers will behave completely differently in biological systems like ourselves. And so one of the real classic stories, and I bet folks have probably heard this before, but a classic story from the 40s and 50s where differences in chirality resulted in severe birth defects, where docs were actually prescribing this med to help women with morning sickness. It was an antiemetic, right? Anti-nausea for morning sickness. And it turned out one of the enantiomers was fine and helped with sickness, but the other one was a really bad mutagen. And exactly as Lacey's saying, yeah, you got enzymatic active sites. They have their own chirality, so they're going to react differently with different compounds. But it was a drug known as thalidomide, and thalidomide was one of the classic stories, really sad and horrible story, but nice there, exactly, where we kind of realized that it's really important to make sure you get the chirality correct, or it can have severe side effects. But yeah, there's actually, if you remember the Billy Joel song, We Didn't Start the Fire, like even in that song, Billy Joel talks about the children of thalidomide. And it's right before an awesome drum solo and all that stuff. But so yeah, it was a pretty famous story, and really commonly told in orgo classes. And one of the things you'll notice about the MCAT is that they often use relevant real-world examples, and so things such as thalidomide would be pretty likely to show up on testing. Not that one specifically, but an example such of that where there was a history and a whole thing that happened behind it. So cool. All right, so there we go. So that's the whole difference is that they are biologically different. But there's also another big difference. Anyone know any other really big differences between these other than the fact that one could potentially be deadly, the other one might be helping? You remember the song too. There's another, and this is really kind of a big difference when we talk about enantiomers, and it's why we classify enantiomers and diastereomers as optical isomers. And exactly as Mariah was saying there, it's because they differ in optical rotation, number one. So the way they rotate in plane polarized light. Now, this is a big point of confusion for lots of people, so I'm going to spend some time actually digging into this for a second. But there's different ways that we can name these isomers. So you can have a dex ibuprofen or levi ibuprofen. And so just to make sure we're on the same page about this, whenever you talk about dexy or levi isomers, that's referring to the lowercase d. So lowercase d means dexy, which means it rotates plane polarized light in the positive, which is known as a clockwise direction. Whereas if it's a lowercase l, that means it's levi ibuprofen and it rotates it in the negative direction. This is in a strong contrast to the other letters D and L. Be aware, dexy and levi, D and L, right, lowercase d, lowercase l, is actually a completely different system of nomenclature than capital D and capital L, which is really irritating because they sound like the same thing, which is why it's very easy to fall for that trap on the MCAT. And so just be aware, this is actually a different system. Capital D, capital L, it's a very old system of nomenclature used to describe sugars and amino acids, and it's referencing a specific chiral center, not rotation whatsoever. And that is also in strong contrast to the other system of nomenclature, which is R and S. So just heads up about this, there's actually 3 different systems of nomenclature that we can use for chirality. You can do capital L, or you could do capital R, capital S, Or you could do lowercase d and lowercase l. These are all completely different systems. So just be careful with that. It's really easy to fall into the trap assuming these are actually the same things. So I just want to, warn you all because it's an easy trap to fall for. All right, so there's another difference as well, and this is what we mentioned previously when we talk about these enantiomers. Not only do they differ in the rotation of plane polarized light, they also behave differently in chiral environments. And when we talk about chiral environments, that is every single biological system, as we said before. Examples of this are things such as ibuprofen's different chirality, as well as oh boy, like we said, thalidomide an example. And you can even talk about things such as, let's do this. Let's get some tricky questions for you. So when we talk about sugars, we often talk about sugars in the context of capital D and capital L. Which of those two are the kind that we can actually eat? That's right, because if you actually get an enantiomer, a perfect mirror image of sugar, we can't do anything with it. Even though it's all the same connectivity, it's basically the same structure, our bodies can't really get any energy out of the kind that we're not used to. It's really, really important to make sure that any kind of biological compounds, like sugars, amino acids, everything, have the right arrangement. And exactly, it is D for sugars, as many people are saying. So it's the sugars that are biologically active are D sugars, right? D-glucose, D-fructose, D-mannose, D-galactose, D-any sugar. Amino acids, though, are L. Well, almost all L. There's glycine's its own thing because it's non-chiral. But so do be aware, amino acids are L, sugars are D. Right, nice. So do be aware of that. And that's why I'm going to try to tie in the more advanced stuff, the biochem, even though this is a fundamental isomerism class. This is the way they test it on the MCAT. It's not just, know your orgo. It's really figure out how it relates. And exactly, and I swear I got the recap. As we said, D sugars are biologically active. L amino acids are biologically active. Nice work. Cool. All right. So that's the end of this part of class. We're going to jump into a series of questions. Now that we've done a bunch on orgo, isomerism, biochem, we're going to jump into some physics and some other stuff, and not just talk about it in terms of the science, but we're going to try to connect the dots once again and really get at the underlying concepts behind things. Should be fun. All right. Cool. All right, so let's begin. So we're going to jump right into some, as you can see, this is science knowledge basics. I just want to warn you guys, some of these questions will be fairly simple for some of us if we've had these classes recently. But just as before, our goal here is not just to answer the question. We want to connect to the ideas behind it, we want to get big picture, and we want to make sure we feel comfortable with the underlying science behind all of these things. Cool. All right, so we'll talk about different scientific principles when mentioned in a question. Namely, we're going to go through 4 questions together as a group. And we'll talk about how these things all relate, how it looks on the MCAT, and what you need to know for test A in terms of just a couple of different topic areas. Namely, we're going to talk about some stoichiometry. We're going to do a little bit about nomenclature. We'll do some thermodynamics even, and even a tiny bit of fluids. We won't get to everything here, though, so just as a heads up, we're going to do a chunk, because as you know, we're going to try to take it and have some fun with it. All right, so now before we get into the science, I just want to introduce you to some of the Kaplan strategies, because the way that you solve problems on the MCAT isn't really the same way that you solve problems in your classes in college. One of the biggest differences, and I know this is what Ali brought up at the very beginning of class, is timing. Timing is a much larger concern on the MCAT than it is in the vast majority of undergrad classes. And so to be real specific about that, it tends to be the toughest for the CARS section, the critical analysis reasoning skills, the one that they used to call verbal back in the day. We're not going to do that today. As you know, this is going to be a Chem Phys class, and we're going to focus on chemistry and physics. But do be aware of all the sections, that one tends to be the hardest. And so one of the biggest pieces of advice I have for everybody here is to practice CARS early and often. It's one of those sections that people tend to not focus on because we tend to focus on like the things that are more observable. You're like, oh, I don't know this yet in biochemistry. I'm just going to learn this in biochemistry. But the thing is, the only way that you get good at cars is by practicing in the context of the test with the timing. And so we do have different strategies for how you approach cars passages and questions versus science passages and questions. And today we are going to focus on the science. But the one cars thing I'll leave you with today is you got to practice it. And don't wait, practice it now. And as Krishna, that's true for lots of people. Man, cars is, I still think, and I think almost every Kaplan teacher would agree, it's the hardest timing of the whole test by a lot. And so it really does means a really big difference to just start practicing it early. So, all right, I won't talk about it more. We'll do more of that later on. But for today, we're going to focus on the science. And so what we're going to do differently, and I'm going to kind of tie in maybe some memories from your physics classes in college. But before you start solving, you want to read the question and you want to glance at the answer choices. Because here's the thing. You can use the answer choices to your advantage. And so let me ask a question. And this is, we'll see who's, please be honest here, because I think everyone's done this before. But have you ever found yourself, usually in a physics midterm or a physics final, it's kind of a big exam, where you get this physics problem, you do, and this is for, we'll say it's a multiple choice exam. Well, yeah, we'll go with a multiple choice physics exam. So if you were lucky enough to have multiple choice physics exams, this might have happened to you once, where you see this problem, you go through, you figure out the equation, you do all the math, you figure out the answer, you look at your answer, and your answer is like 372.6. And then you go look at the answer choices, and all of the answer choices are like pi 4 over radius, or like 3r over like distance. And all of the answer choices are just defined in the context of some kind of a variable or some kind of a constant. And then you have to go back and redo all of your work to figure out what the answer would be using that variable instead. And it takes like a couple minutes, not to mention the several minutes you spent in the first place. You don't have time to do that on test day. As you can see, lots of people have done this before. So one of the things, exactly as Mariah's saying there, you want to first glance at the answers and say, oh, cool, all the answers are in terms of radius, or they're in terms of pi. And then you can use that to your advantage. To go one step even further, you can mine these answers for information. So if you look at all the answer choices and you say, oh, cool, the first one is, we'll say the first one's 100. The second answer is 10,000. The third answer is 1,000,000. And the fourth answer is 10 billion. If your answer choices are really far apart like that, you can round as much as you want. Like you can change an 8 to a 10. You can change a 2 to a 1. You can round however you want and only solve for the general order of magnitude and still be very confident in what your answer is. Now, your main goal, not your main goal, but a very large goal of doing any kind of math problems in the MCAT. Since we're doing physics now, we're going to dig into a little bit of math. You want to avoid putting in any time that is not necessary. And as Mike says, don't plug and chug when you can just round and round. Mike likes to say that. But that's the idea. So you want to put in as little work as possible. You want to use the patterns exactly to your advantage. And so we'll try to keep that in mind with all of these. Don't do any extra work. Do just what's ever needed to be confident that you're going to have the right answer. Cool. All right, so that's my first thing on assessing, right? It's not just the question stem itself. It's use the answers to your advantage as well. And you'd be amazed how useful the answers can be on test day. Really is going to be a huge benefit. All right, so now once we've got that plan of attack, right, so we know what we're going to be solving for. It might involve plugging in an equation. It might involve just eliminating wrong answers. It could involve using the answers to your advantage or not. We want to figure out like what we need to do. So like what's being tested, what equations do we need, how much work's required. And one thing to keep in mind, and I know Ali brought this up previously, remember that on the MCAT, every question is worth 1 point and only 1 point. You never want to put in any extra time if you're just going to get a single point for it. And so this is one of the biggest problems for most test takers because we're smart. Seriously. If you're taking the MCAT, if you're even preparing for the MCAT, that means you already got through all of, or at least most of the pre-requirements for medical school applications, which means you've done well enough to be at this point. You have to be intelligent. It's a prerequisite to even be here today. But then the problem is, people that are intelligent, if they know how to solve a problem, they really want to solve the problem because there's this pride involved with it. You're like, oh, cool, I can do this. I'm going to do it. But the thing is, if it's going to take you 4 or 5 minutes to plug in all the numbers and solve it, you're actually hurting yourself. You have to realize when it's to your advantage to actually fold your cards and say, all right, I can actually solve this problem. I know how to do it, but it's going to take me a couple minutes. And so the better thing for you to do is to guess and move on and find the questions that you can get done sooner. And this is what I've heard. One of the hardest things for lots of us, because we are smart, we like to solve questions. It's a challenge for us, but you got to realize sometimes the best thing you can do on test day is actually not even bother with that question. Like, this is going to take too long. Screw it. Circle something. Keep moving. It's going to take some getting used to, but you gotta keep that in mind. All right, so that's part of your assessing right, figuring out what your plan is, and honestly, sometimes your plan is just to skip it altogether. Be aware of that, right? In pre-med life, as you're saying, so true. And oh my gosh, as I was saying, they will prey on you for that as well. Like, they're going to try to give you questions that they know take 10 minutes just to see if you waste the time. In fact, here's an interesting anecdote. I've been teaching MCAT for a very long time, and so one of the really old AMC exams, this is from about a decade ago, they actually had, and this is actual AAMC stuff, they had a real MCAT with a passage, and that passage had a single question on it. Seriously, they made an entire passage with just a single question. And so what they were doing there, at least what I'm assuming they were doing there, was to see if you would actually waste all of the time to bother reading this passage to see if you could solve this question. Because the thing was, after you put the 3-4 minutes into reading it and solving the question, you're at least 5-6 minutes committed for a single point. And so my theory is that they probably even made passages like that just to see if people would waste their time. Now, that was a long time ago. That was over 10 years ago. I don't think they would do that anymore, but it's an example of what they are thinking, and they're trying to think, are you being logical and strategic with the time they're putting in? So I think it's a fun anecdote from the past. But yeah, I don't think they're going to do that anymore, but they're still going to try to make you waste time. All right, so there we go. So we're going to make your plan, decide if we're going to do it or not, figure out what's being tested. Once you got your plan of attack, then you can basically execute, which, as we said before, sometimes it's easier to figure out the wrong answer than it is to figure out the right answer. And so sometimes guessing, moving on, eliminating, or potentially matching for the exact answer will be the way that we solve these things. All right, so what we're going to do together now, we got another 20 minutes or so to work through this stuff together, and so we're going to go through a series of 4 questions. But before we actually solve, before we even give you the multiple choice pods here, or polls here, we're going to just talk about the background science, like what you know about this, what's the background principles that are required to solve questions such as this. All right, so here's a little bit of a map, and I've been doing this the whole class, but remember, what the AAMC is going to try to do is not just have you solve questions and know content. What they're going to try to do is to test you on the relationships between these concepts. And so that's why things such as, oh my gosh, like biochemistry is so good at this, because biochemistry includes things like nomenclature and reaction analysis, as well as intermolecular forces, like hydrogen bonding in DNA, or the different types of charges in your amino acids. Like, they're not just going to test you on these concepts in isolation. It's how everything relates to the other topics. And so this is just a bit of a map to, like, this is an example, but to show you that it's really not the science topics themselves, it's how they relate. So that's more than anything else. Cool. All right, so let's jump into our first example here. And so we're going to start with this. And so just let us know in the chat. This is pretty open, but what do you know about heat transfer? Because as you can see, this specific question is talking about what type of heat transfer is the primary way that the sun's heat reaches Earth. And so there's tons of stuff you can say here. But what are some of the things you know about heat transfer? Super open-ended. So we'll give you guys some time to think about this, but throw it in the chat. Nice. You got it. Radiation's a good example. Entropy is a big part of thermodynamics. So this is a thermodynamic topic. Exothermic's a good example of thermodynamics as well, where we have energy leaving the system, right? Endothermic energy is going in. We've got conduction, radiation, and actually, I don't know if I saw it, but there's a third type as well. I think someone might have already said it. In terms of specific to heat transfer, not just thermodynamics in general. But nice, convection, Jane's got it, as well as Joey, a bunch of other folks as well. And so those are the 3 main types of heat transfer. couple of things I want to mention, though, about heat transfer in general. Heat is a flow function, if you want to be real specific. It's not a property of a system itself. It refers to energy that's either entering or leaving systems. And these are the three main ways that heat energy, specifically, can either enter or leave systems. There is no such thing as transferring cold. There's only transferring heat. So if you think of yourself going outside, the reason that you get cold isn't because the cold's getting into you. It's because the low temperature air outside is bumping into your body and sucking the heat out of you. It's that you're heating up the air. If you heat up all the air around you, that means that you're going to lose your own heat. And so that's a huge part of thermodynamics in general. All right. So yeah, there we go. And so radiation, a couple of different things. People already broke this down. But radiation is via electromagnetic waves. And yes, the sun is definitely emitting electromagnetic waves. But do you emit electromagnetic waves? Like you as a human? Do you actually emit these too? And if so, what kind? Because we like to think of it as the sun. Like, yeah, the sun's shining visible light. And lots of other radiation too, like gamma rays and X-rays, which usually the atmosphere filters out so we don't get too much cancer. But we ourselves, are we hot enough to emit radiation? And notice this isn't radiation as in like atomic decay. This is talking about radiation as in terms of heat transfer. And notice that's exactly, Aishwarya is saying, you are radiating excitement, Aishwarya. That's perfect. But we as humans do. We actually radiate energy as well in the infrared spectrum, as Hilary Nasani is saying. Exactly true. That's why you can actually look at a human with infrared goggles. It's actually picking up electromagnetic radiation within the infrared side of the spectrum, right? Infrared means below red, so it's even lower energy than red. And this makes sense too, because if you think of high energy systems emit higher energy radiation. That's why if you, for an example, if you take a piece of metal, you stick it in a fire, as that piece of metal starts to heat up, it's going to start emitting infrared radiation as it gets hot. And as it gets hotter and hotter and hotter, eventually it'll start to glow red. And as it gets hotter, it starts to move up the electromagnetic spectrum. Then it's a little bit of an orange light. Then it's yellow. And eventually it'll be so hot it looks white hot. And that's because it's emitting all colors of the infrared spectrum. And then if it got even hotter than that, which I don't know you can do with just metal, it'd start emitting ultraviolet and X-rays and gamma rays. But once you're up that high, you're talking like something as hot as the sun. So hopefully that's not possible with just heating up metal in a fire. There we go, there's radiation. Conduction's all about direct collision. So I mentioned this before, but so if you step outside and an air particle bumps into you, that's conduction. If you grab onto something hot, that's conduction. If you ever have atoms colliding with atoms, that's what conduction is. What about convection, though? What's like the key for convection? Because it does include also some contact, but there's more of a specific thing that we talk about with convection. And if you're not sure, think of examples. Like we know of convection ovens are a good example. If you have access to a really fancy freezer, there's also convection freezers. Those are real expensive though, so I doubt they're in anyone's houses. But you can also think of, there's some common terms for convection when we talk about the weather. So for example, if it's outside and it's cold, it's going to feel a whole lot colder if it's windy. And I like how Julie is saying fluid specifically, because fluids refer to not just liquid, but also gases, as Lauren's saying. So if you ever have the bulk movement of fluids, and be aware, fluids are both liquids and gases, that's what convection is. And so the way that you basically, what a convection oven does, is you just have an oven with the fan in the back of it. If your oven has a fan running that's blowing air over your food as it cooks, it's going to cook it even faster. Hence convection oven, because it's using the movement of air to cook your food faster. Same thing when you talk about the wind chill, right? The reason it's colder when it's windy out is because that moving cold air is going to be better at pulling heat out of your body. Cool. All right, so there's a bunch of examples about heat transfer. We'll do a couple more examples before we solve these, and we will give you a chance to solve these 4 questions too. All right, so before we jump into this next one for solving, let's just talk about some backgrounds in terms of organic chemistry and naming conventions. So just let us know what you know about the factors about that influence the IUPAC name. As you can see, this question is all about nomenclature for this specific compound. And we'll give you a chance to solve this with a poll, but this is once again open-ended. Like, what are factors that influence naming? There's lots of things. I know previously we talked about oxidation state. Nice. So we talked about how the highest priority groups are the most oxidized groups, which is why we talked about the aldehydes, the carboxylic acids, exactly as Mariah Lister was saying, the number of carbons, right? So it's the priority of your functional groups, the number of carbons in your chain. Nice, the types of bonds, as Julie's saying, double versus single versus triple. Nice. And so those are the kind of the biggest factors. So you want to figure out your highest priority group, the number of carbons in the chain. You gotta know these prefixes, right? So meth, eth, prop, but, pent, etc., etc. I'm assuming you guys already have this stuff memorized, as well as the nomenclature for really common functional groups. You know, like everything from ketones, aldehydes, alcohols, esters, amides, anhydrides, oh my gosh, amines, amides, all that stuff's really important. Different ring structures, exactly, aromatic conventions. So you gotta know your nomenclature. But the thing is, it's not that the MCAT's gonna be giving you a bunch of nomenclature questions. It's that they're gonna just say the name of a compound and then ask you more advanced questions on it, where if you don't know the nomenclature, you're not gonna be able to figure out what the structure is. And so do be aware of that. It's not often just straight nomenclature. It tends to be more complicated, but if you don't know the nomenclature, you can't solve the questions. Cool. Nice, and Alex has some good breakdown there too, but yeah, exactly. All right, so let's do another one. So yeah, we already talked about functional groups and locations. And one more thing, if people are taking down notes on this, remember the highest priority group gets the lowest number possible. And also remember that the highest priority group means the most oxidized group. Right, so that's why we said carboxylic acids are good examples. Yes, oxidation means, generally speaking, more bonds to oxygen, but using your Gen Chem definition, which is even more true, is the more loss of electrons. Remember, oil rig, right? Oxidation is loss of electrons, and so that's why forming new bonds to oxygen is so oxidizing. Because oxygen's so electronegative, it's going to be pulling all of the electron density away from your carbons, thus oxidizing them, right? Your carbons will lose more electrons. So it's really all the same thing. Cool. Oh my gosh, the jokes are over the top. It's awesome. Awesome, and there we go. All right, so there's some IUPAC rules, as we said before. Let's do a couple more. So we'll do, as we said, we'll do 3 questions. We'll have you actually solve them all. We're just kind of doing some introductions here. So let us know, what are some general properties of liquids? Because notice we've got a question here all about something that is true of liquids, but not true of gases. And generally speaking, on the MCAT, when you get questions with this word, the most important word in the whole question stem is the not. This is awesome. So I like Simone's bringing up convection, right? Because convection requires fluids. Really good point. We can talk about induction effects. Oh man, we could get into that. Compressibility is another thing we could talk about. Ability to flow. They take the shape of the object. There was actually I forgot what they call these awards, but someone recently got a science award where they basically just make funny studies, and it was someone trying to prove whether or not cats were considered a liquid or not. Because the thing is, as you guys are saying, liquids take the shape of the container that they're in a 2-dimensional sense, right? Not 3-dimensional, they won't fill the whole container, but cats are really good examples of objects that whatever container they find, usually a box, they're just going to squeeze right into it and fit perfectly into the shape of the container that they're in. And so someone actually wrote a paper trying to argue that cats were liquids and won an award for it. It's kind of absurd, but yeah, that's the kind of thing that if you look on the internet for science jokes, you'll see them. Density is another good one, Mallory, too. And we know that liquids are more dense than gases. Gases, of course, are less dense, you could say. They allow free movement. They take the shapes of the containers that they're in. Exactly, and as we said, gases have the highest speed, right? So the higher gases, of course, basically are moving around faster. Liquids are slower. And then, of course, solids are the slowest. And you got it. Exactly. If it fits, I sits. You got it. Oh, man, these puns are over the top. I need to start taking notes of your guys' puns because they're really good. All right, so here's a couple examples. So let's do another one. So we'll do this one after this. As I said, we're going to actually go through and solve all these with multiple choice context. But as you can see, this question's all about hydrostatic pressure and how it's going to change in different environments. So what are some things you know about hydrostatic pressure? And so one thing I'll start with here, as people are answering, nice, is word roots. Notice hydro word root. Let's label this. Refers to fluid. Hydroelectric power plants. Static, and I'll do a different color here so we can label this color-coded, refers to things generally being still. Right? Static, you know, like not working, not moving. You know, static friction, for example, in physics versus kinetic friction, moving friction. Cool. And so, yeah, so we're talking about things, so actually, Trevor's got a great point about hypotonic versus hypertonic. Technically, that would be either osmotic or oncotic pressure, not hydrostatic pressure. But it's a good thing to bring up because we do often talk about, it's called Starling's forces or Starling's law, but it's the balance in blood vessels and capillary flow that's countering the hydrostatic pressure versus the oncotic pressure, you know, like how concentrated your blood is versus, you know, like the pressure of the blood. But exactly, yeah. So for hydrostatic specifically, though, that wouldn't be concentration differences. That would be more of like how much your heart's pumping and actually forcing the fluid through it. You got it. Technically, that'd be static, not hydrostatic pressure, but it's the similar idea. You got it. But yeah, Julia's got a good breakdown. It's the pressure exerted from not always a liquid. Actually, a fluid works too. Even gases apply hydrostatic pressure on the walls container that it's in. But nice work. And so, yeah, pressure, this is force per unit area. And, you know, since everyone's being so silly, I would love to give you guys a joke, too, about pressure, just because Ali and Aishwarya are giving really good jokes. So I'll try to give my own joke here. But there's a nice way to remember the units of pressure. And anyone actually know what the unit of pressure is, like the SI unit of pressure? Notice that it's force per unit area. So it's newtons per meter squared. I'll try Ali. And so that is known as a Pascal. And so notice a Newton per meter squared. That's a Pascal. And here's my cheesy joke for you to remember on the unit of Pascals. Nice work, Denise and everybody. You got it. All right, so here's your cheesy joke. So let's say that Einstein, Newton, and Pascal, they're all hanging out in heaven because they all died a while ago. So we'll say they all went to heaven because that's fun. And then they decide to play a game of hide and seek. And so they're hanging out in heaven, decide to play a game of hide and seek. And Einstein says, all right, guys, I'll count. Einstein, and then Newton, Pascal, you go off and hide. And so Einstein turns around, starts counting. And then Pascal runs off and hides. And then Newton goes to hide. And then halfway through hiding, gets an idea. And instead walks back to where Einstein's counting, takes out a piece of chalk, and then draws a perfect box, 1 meter by 1 meter, and stands in it. And then as soon as Einstein's done counting, he turns around and says, dude, Newton, I found you. You're terrible at hide and seek. You didn't even hide. And then Newton says, no, no, no. You just found 1 Newton per square meter. You found Pascal. It's really kind of a heavy, cheesy science joke. But it's one of my favorite really weird jokes. And so tell your friends, tell them they got to know what a Pascal is. It is a necessary unit of measurement for you to know in terms of SI for the MCAT. And so we'll leave you with that just since I'm trying to make some jokes since there's so many jokes going on. We also, if you haven't realized, we Kaplan teachers like to be silly whenever possible, because one of the things you might have learned is that the more people have the context, it's either silly, funny, or dirty. I know dirty works too. It makes it easier to remember. And so there's going to be so many dirty, filthy mnemonics that you learn in medical school. We'll try to avoid the filthy ones just because, you know, you're not in med school yet, but just be aware it's going to happen a lot in your future. So, you know, we'll bring out the cheesy ones for now because, you know, we'll try to avoid the dirty ones, though. All right, so there's a couple of things mentioned. Force per unit area. This is the full formula for hydrostatic pressure. That right there also is, I just want to label this so you can see it. That's the ambient pressure, which is often atmospheric. So basically, you're taking the ambient pressure plus, actually, I'll just define all these terms here. So rho is equal to density. G, of course, is gravity. You all know that one. And then H is equal to depth of the system you're talking about. Cool. Oh, and Samuel, it's so true. It's, yeah, there's very, 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 very filthy jokes that you're going to see lots of in med school. But they've actually done a lot of studies and have found that actually the dirtier the mnemonics are, the more likely people remember them, or the funnier they are. I mean, that's why we just try to give you funny jokes, because, you know, we try not to be too filthy. All right, so we got about another 10 minutes or so. So let's do these polls. Actually, Allie, if you don't mind grabbing the poll for question number 1, we'll have you all solve this. As Ali says, we have a learning science department that spends a lot of time researching what's effective and not effective. So we kind of nerd out on like learning science here at Kaplan, which is fun. Yeah, and Sawyer, I think that's my favorite comment yet. Nice. Perfect. We got 97% of you. Impressive work going for the right answer here. It is, in fact, radiation. In fact, the only type of heat transfer that can happen through a vacuum is radiation. That's why, I don't know if you guys have seen these before, but those really fancy Yeti mugs or Yeti coolers, that's just one brand, but they make really good ones. All those really expensive, nice thermoses, the reason that they're so expensive is because they're double-walled vacuum sealed, where what they'll do is they basically put a container and then a vacuum seal and then another container. And so even those expensive coolers, they do lose heat via radiation, but they prevent heat loss through convection or conduction, which means that it's gonna be much, much slower. And so they will eventually reach equilibrium with their environment. Everything will eventually reach equilibrium with their environment, but it really, really, really slows down that transfer. Cool. Cool. All right. Let's do number 2. We'll do the same thing as before. If you don't mind, Allie, flipping out that poll, we'll have you guys vote once again. I'll just get quiet while you guys are voting. So I want to talk about some polls that we have right now, because we are primarily split between 2 different answer choices, B and D. Nice work for, yeah, so we're basically kind of splitting back and forth. But so here's the thing. This is some really good strategic work, because it's going to take us a little bit of time to figure this out. So what we can do to be more efficient is to identify something that stands out. And what was the thing that everyone noticed in B and D, and let us just quickly eliminate A and C, because I will cross these out as you all did. No one likes A. Well, there's very fewer votes for A and C than the other 2, and nice work. Notice what stands out is we've got 2 chlorines at the end, right? And since you know you have 2 chlorines, you know that you're going to have to dichloro. Dichloro, dichloro. If you look at all the answer choices as well, notice all the answer choices, for everybody, end in O8. O8 is the IUPAC name for an ester. So our highest priority functional group is, in fact, an ester. So once we got that, we're like, all right, so it's either dichloromethyl-2-buteneoate, or it's 2-butene dichloromethaneoate. So we want to find out what our longest carbon chain is. And so either it's a 1-carbon chain, or a 4-carbon chain. And as you all can see here, this right there, that is your carbonyl carbon, the one I just drew in red. In fact, I'll just draw it right here. So that is your carbonyl carbon. And then everything going to the left of that would be your 4-carbon chain. 1, 2, 3, 4. And then off this, you've got an oxygen, and that oxygen's got a carbon with your chlorines on it. And so be aware, whenever we identify the highest priority group, whenever we identify the longest carbon chain, the longest carbon chain must contain the highest priority group. And in this case, your highest priority group is that ester there. It's got to have this carbon in your root chain naming, which means it is, in fact, 4 carbons that we have most of us going for now at this point in the chat. So really nice work. So we got the 4 carbons of the butte. You got the dichloromethyl as well. I'm going to move this over. As you can see, the answer is circled, but I want to draw the full structure. And actually, out of curiosity, does anyone notice what I'm missing in this structure? And I'll move it because I just know that text just covered it. But there's one thing I didn't draw that's actually necessary for this to be correct. And you can tell from the name, notice it is dichloromethyl 2-buteneoate. Well, the hydrogen doesn't need to get drawn all the time, but nice, the double bond, Anise and Joey saying it first. Good work. Notice it's buteneoate, not butaneoate, and so it's actually on carbon number 2 right there. And so you can also infer from the lack of hydrogens there, you only got 1 hydrogen on each of those carbons. You can infer it there too. But notice you didn't even need to do that. All you had to do to get this question correct was first realize you got 2 chlorines, get rid of A and C, and then realize, oh, it's at least a 4-carbon chain because that's where your carbonyl is. So it's got to be answer choice B. Nice work. Cool. Oh my gosh, as I was saying, so true. Overlapping patterns is really where it's at. Really good work. All right, we got 2 questions left, so let's knock them out. So same thing as before, if you don't mind grabbing that poll, please throw them in for question number 3. So we have a good chunk of you voting, then we'll talk about it. Nice work. So we got most of us, pretty vast majority, about 78% or so at this point, going for the right answer. Good call. Because the thing is, remember, liquids and gases are both fluids. We mentioned this before. And fluids can form to fit the shape of their container. Gases on all walls, right, they'll expand upwards as well. Liquids stick to the 2-dimensional phase, right? They'll expand, but basically only as much as they have to be stuck on the bottom, like a cat. And so, good call. They are, gotcha, cool. Yeah, so yeah, you guys are right. They do both conform to the shape of their container. That is a true statement of both of them. Let's look at C. So C says larger constituent molecules will move at lower velocities given equal temperatures. That is actually a true statement, true of gases. So the thing is, large gas particles move slower. And does anyone know why? Like, if you have 2 gases at the same temperature, a certain property is the same, which results in the velocities actually being different. So do you know what is the exact same for 2 different gas particles if they're at the same temperature? It's kind of as a nice bridge between chemistry and physics, actually. Which means if you got a larger or heavier gas particle, it is going to have a lower velocity. Nice work, Jason. Ava saying the same thing. They have the same kinetic energy. Good work. Which of course is 1/2 mv squared. You do need to know your formulas for that physics. Good call. So that's actually a true statement, which remember, the answer choice we're looking for is a false statement. And they also exert pressure on the objects contained within them. If you fill a whole container full of liquid, it's going to apply pressure to it, whether it's liquid or gas. Nice work. And so as we said, gases are the least dense. They have the greatest particle speeds, right? The highest entropy as well. People brought that up in the chat previously. But in this case, remember, gases are very compressible, whereas liquids are incompressible. Super nice work. All right, so final question. Let's throw your answers in the polls for this one. It looks that's a little strange that it's showing. I'm going to try to cover that up, actually. Cool, so cover all that up. There we go. Sorry. So same as before, throw your answers in the polls for question 4. We'll give you about a full minute for this one, actually, because this is one of the trickier ones. So use logic, though. Try to avoid doing any actual math. think about relative relationships and where it'd be greater, Earth or Moon. Okay. All right, so let's think about this again. So hydrostatic pressure, nice, it's getting better. This is the pressure due to stationary fluids. And now remember, fluids mean both gases and liquids. So just logically speaking, if air and liquid are both going to result in your hydrostatic pressure, where would you get more hydrostatic pressure? On the moon or on Earth? Just kind of like logically speaking, given that we know the differences between the Earth and the moon, we know that the moon is actually a vacuum, right? You need to wear a spacesuit to walk around there. The Earth, we've got actually a really dense atmosphere. Our atmospheric pressure here is 100,000 pascals. That's like the standard atmospheric pressure. And so, yeah, since Earth has higher atmospheric pressure, you can basically solve this problem by not doing any work at all. There's no way that the moon could ever have higher hydrostatic pressure because it doesn't even have an atmosphere. And what's the other factor, too? There's one other factor as well that affects hydrostatic pressure, that the Earth is greater as well. Remember, this is your formula for hydrostatic pressure. Oops, let me get rid of that. So we know that the Earth has greater hydrostatic pressure because it has both greater atmospheric pressure, and it also has, notice one of the factors that affects this that we know is different between the Earth and the moon is that you have to include lowercase g. Acceleration due to gravity, exactly. The Earth has way bigger gravity, it's got way bigger atmospheric pressure, and if both of these two terms are always greater for the Earth, then there is no chance that it could ever have the Earth being less. So your only option, of course, is answer choice A. Now notice there's other ways you can solve it. If you want, as you can see on the slides here, you can think of it as a linear equation, right? Y equals mx plus b, because all these graphs are linear. And think, okay, well, let's figure out what the difference is in slope. That's your m term. Let's look at the differences in y-intercept. That's the b term. But you don't even have to. All you got to do is say, all right, greater atmospheric pressure, greater gravity. Moon's got nothing going for it, so there's no way that you can ever have moon greater. And notice that moon's greater for everything in C. Moon eventually becomes greater in B, and moon eventually becomes greater in D as well. And so really the only option choice there is answer choice A. Whew! All right, we did it. Really good work today, guys. We just ran through a completely mix of organic chemistry, biochemistry, physics, gen chem, whole mix of everything, and it's been so much fun working with you all. And so I'll be hanging out. If you have any questions, let us know. But Allie's going to be jumping right back on. She's doing a little bit more coaching before we call it quits for the day. But it's been fantastic working with you all. Hope to see you all in the future MCAT classes. All right, Allie, whenever you're ready, take it away.
Oops, I forgot to turn my microphone on. Hello. Hello. How did you like that? How do you like John? I think John is so great at breaking these tougher science concepts into like simpler things. Remember yesterday when I was telling you that if you can just get it down to the simple science, if you can just figure out how to cut through all the noise, then you can do a lot better than you think on this test. You just got to kind of cut through that noise and break it down. I like to call it chunking, right? You break it into chunks. When I was first getting into fitness, I'm really into fitness. But when I was first getting into fitness, I was not really into fitness. And I went one day to this boot camp in the park, and I didn't know what that was going to mean. I thought we was just going to do some light exercise, get ready for our days. But boot camp is actually really scary. And I showed up, and they said, it's long run day. And I was like, what's a long run? I never even take the short run. And they were like, it's a long run day. And so we started running, and this little trainer was running circles around me. And she was like, you can do it, Allie, you can do it. And I'm like, no, I can't do it. And she said to me, and this I think is true all over the MCAT. I think it's true everywhere in life. She goes, Allie, but can you just get to the trash can? Can you just get to that trash can over there? And I'm like, okay, I can get to the trash can. And then later she's like, can you get over there to the light post? And I'm like, oh, okay, I can get the light post. And then it was a corner, and then it was another light post, and another trash can, another corner, and then it was like the guy standing there, all of these different things. And I realized by the end of the day, I had run my first 5K, and I had never run in my life. And now I ran a 5K on my very first time running. And, you know, it was a big revelation to me that I could, if I chunked things down, I could be more successful than I ever imagined. And I think that a lot of what John taught you today is very similar. We got to chunk it down, right? When you look at the whole mountain, you think, I can't climb that, right? But if you just look at each individual trail, you're like, yeah, I could do that trail. So don't look at each one of these questions as like a mountain to climb. Just look at the little pieces. What do you know? What can you eliminate? How can you get it smaller? So I'm really excited. Yeah, listen, Shebang, that boot camp was legit. Have you guys heard of this? Like a runner's high? I got a runner's high on my first ever run. It's like where you run so much that you just get like, you really go into like a euphoria, and it was crazy. We're going to go back into my classroom now because I promised you some coaching today, and I'm really excited. And you know, all of these coaching sessions, I've never done coaching in a group. I've never done that. I always do my coaching, and Kaplan Plus coaches are always one-on-one with their students. So in my coaching sessions, I'm trying to figure out like how I can make coaching as broad as possible so it can apply to everyone. And I'm always thinking about the topics that my students ask me about to help them with the most. And that's what I'm trying to provide to you. But listen, I know it's not super personalized like I would do for my students. Like I would do this with them, I would help them, and I would personalize it to their situation. But don't forget, you have me for coaching outside of class as well. You can email me. It's not face-to-face like it is with my students, but it can't be nothing, right? I think that I'm pretty cool, right? So just email me if you need any help with anything or personalizing this or figuring out how it applies to you. And my email is right up at the top. But let's talk about today's subject, which is timing. The do's and don'ts of clock management, because as scary as that clock is, all tick, 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 ticking down, you got to work with it, right? And you have to work it to your advantage. And so you have to learn very early on, how are you going to treat this clock management? And you guys know how I love to ask you if you're willing to admit stuff. Is anybody willing to admit, like if I put up some of these bad habits, can you just be willing to admit? Because I want us, one, to talk about what they are and why they're bad. And two, I want everyone to see that you're not alone and understand that these are very common to everybody. So I hope that you will join me in admitting some stuff. And I will fully admit that I have done all of these bad habits in the past, and I have replaced them with all the good habits to the tune of actual points on the test. So here we go. Here we go with bad habit number one. Obsessing over the clock. Me, right here. So much that I remember at one point just watching the clock tick. And I'm like, I don't know how to answer this question. And I'm looking at the time. I don't know how to answer. And I'm looking at the time. And then I'm like, oh my gosh, all this time just passed because I'm like staring at this clock. Has that ever happened to any of you? Thank you, Ashwarya, for not leaving me hanging on that. Really, nobody wants to admit that they have obsessed over that clock and got distracted by it. Oh, thank you. Thank you for admitting. I want you guys to see that you're not alone. I've done this before too. And I had to replace it. And replacing meant a lot of practice and doing the right thing until I had replaced the bad behavior with the right behavior. So I don't want you to do that. So we're going to replace obsessing over the clock with pacing yourself. If you practice on your tests and you give yourself the right amount of time and you learn to let go of some stuff, you learn to mark and review like we did yesterday, and you pace yourself on questions appropriately, you will stop obsessing over the clock. Because I tell you what, with enough practice, what I was able to do was feel when I was taking too long with the question, or feel when I got it done quickly, because I had so much practice and I knew exactly how long I could spend before I needed to guess and move on and mark it if I want to come back. And I could feel it. I do this. Does anybody wake up before their alarm clock? I know some people are really heavy sleepers, but is anybody like me and you can actually wake up right before your alarm clock goes off because your body just knows what time it is? Like, I'm totally like this. Like, if I set my alarm for 7 o'clock in the morning, I will wake up at like 6:50 and I'll be like, oh, okay, it's time to get up. So like I rarely ever hear my alarm clock. The same will happen to you if you get enough practice. Even when you practice just individual questions, if you put that timer, remember we want to use the timer counting down so it's realistic. If you put that timer there, it's counting down, and you learn to like know what that cutoff point, know how to guess quickly. Like if you look at it and you know, I don't know this, you're not going to know it by looking at it for 10 minutes. You don't know it. Guess using your patterns and move on. Come back if you can later, right? But the more that you practice with the time and the full lengths and individual questions too, and just you will be able to do the same thing. You will feel when you're taking too long. You will feel when it is time, right? So that practice, that continual practice with pacing is what is going to help you to stop obsessing over the clock, because you don't need to watch it anymore. You know when it's time to move on. You know when it's time to do anything that you need to do. You know when you've gotten extra time because you answered something quickly, or you've picked up extra time because you guessed and moved on when you were supposed to. And so, Samira, I never go back to sleep. I used to. But what I found is that if I go back to sleep and then I wake up, I'm like way more tired. I don't know about y'all, but I can't go back to sleep for like 2 minutes or even 10 minutes or even like 30, because then I'll be super tired. Like if I could just go with the time I wake up, I'm okay, but I can't go back to sleep. So let's talk about the next bad habit. Next bad habit, comparing yourself to others. Have you ever, when you're sitting on this test, thought about, other people that you're practicing with, or your little study group, or friends that have made it before, and sat there and thought, I know they would be done with this question, or I know Teacher Allie would be done with this. I don't know why I'm spending so much time. Like, oh, I wonder, even sometimes comparing to yourself, like, oh, I'm sure that I missed that question back there. And you're thinking about that question from that other section, and you're comparing to like yesterday's self, like last section's self. Don't do that, because you are you, and your whole focus needs to be getting you to your finish line. Who cares about anybody else? I don't care about nobody else. I don't care about nobody else. I only care about me and how successful I can be. I don't even care about past Allie. I care about current Allie, because current Allie will become future Allie, and past Allie doesn't matter. And so the good habit is honing your strategy. You compare yourself to others because you don't feel confident in yourself yet. But you are not going to gain confidence by looking at someone else. Someone else's success story isn't going to make you confident about yourself. Someone else's failure doesn't mean you're a failure. There's nothing that you can, it's apples and oranges. There's nothing you can compare yourself to someone else that will give you confidence. But if you hone your strategy, if you know how to see the patterns, if you know how to break it to the simple science question, if you know how to time yourself and move efficiently, all of a sudden you're not comparing anymore. You're just ticking off boxes. You're just checking off boxes, right? I'm timing myself. I know what time it is. Hey, I see some patterns. Let me investigate this. What do I remember about this specific thing? And you're just, everything is step by step. At first the MCAT is like that mountain, but then when you break it down and you chunk it into strategy and questions and what to do with their time and how to move efficiently, all of a sudden it's not about this worry about other people. You don't have this constant voice in your head telling you what happened with other people or what happened with you in the past. All of that is quiet because you are checking off boxes the whole time you're taking the test. The whole time. All right, here we go. Overthinking the bells and whistles. We talked about bells and whistles yesterday. Remember when we talked about the CBT tools? Did y'all yesterday when you took your practice test, or ever in the past, have you guys ever been like, oh, what are all these features? How often should I use these? I think I should use this because it's here, but I don't know how to use it. But I don't know. Like, should I use it? I used to do this. When I took my first practice test, I'm looking around and I'm like, oh, look at this format here. Like, oh, I feel like I should be highlighting because there's a highlighter. I wonder, and then I'm comparing myself to others. I wonder how many other people are highlighting. How much should I highlight? Like, oh, here's this elimination feature. Oh my gosh, there's this review feature. I don't know how to do that. Don't worry about it. Don't overthink it. The way that you can fix it is just practicing with the tools. And we talked yesterday about how much you should use each tool and where on the test. But I promise you, with enough practice, you're not going to worry about those features anymore. You're not going to worry if you're using them too much or too little. If you get enough practice with just using them, you will learn what works best for you, right? You will learn and say, okay, you know what? I don't actually need to highlight that much. Just like yesterday, we talked about when you sit in a class and you end up highlighting everything because you're worried about it. So you start to say, I actually don't need to highlight that much in this class. Or I actually don't need to check and review my review that often. I know when it's time to check my review. I don't have to use the periodic table so often. I know when it's time to break that out. right? So it's all about practicing in the realistic way with your CBT tools. You want to know how they work and how it works for you, but that will take away that kind of fear and that bad habit of consistently looking at the different features, including the clock. But the biggest takeaway for me and for timing is really to learn through practice. You need to practice with realistic materials. You need to practice with tests that have the CBT tools. It needs to be structured just like the real MCAT. You need to utilize your strategy, and you need to begin timing yourself at a certain point. Now listen, if you're not so great on the content, I don't want you timing yourself. I want you to learn the content and do practice questions untimed with your notes out, right? We're not testing ourselves consistently. You have to learn something new before a test score is going to change. But once you feel like pretty good at something, I want you to start timing yourself with a timer that counts down. And Joey, you know what? If you think that you highlight too much, then maybe do an exercise where you highlight like the least, like even on paper, like if you have some questions or you have a passage or whatever, just highlight the least that you think you can get away with. And the next time, try the least more. Try and cut it down until you get there. Oh, a CBT is a computer-based test. Sorry, it's a computer-based test, so it's different. It's different than what you're probably used to. Most of us take paper-based tests. And so in order for us to feel comfortable in this computer environment, we need to practice with those CBT tools so that they don't seem new and shocking and how do I use it? They seem like what you do on paper, right? Because I'm sure you've crossed out answers on paper. I'm sure you've highlighted stuff on tests. I am sure that you have looked up at the clock on the wall. All of these things that are in the computer-based MCAT, you are used to using outside. However, you may not feel like you know how or how much to use it or how to translate your paper-based test skills into a computer-based environment, but you can fix it, right? Stop overthinking it because it's what you've always done. It's just in the computer format. And when you get enough practice with those tools, it's not going to seem scary or new. It's going to be what you've always done on tests. Does that make sense? Does that make sense? I want it to be like, oh, I'm just taking a paper-based test, right? Take away the smoke and mirrors. It's like when did you guys ever see The Wizard of Oz, and she finally finds the wizard and behind the smoke and mirrors, and all of a sudden the wizard is like, I've seen you like an everyday person. You're like an everyday person. You're not anything special. It's the same with this test and the way that the test works. Once you pull back the smoke and mirrors, guess what? It works just like a paper-based test. You're just not used to those tools, but you can make yourself used to it. And then you can employ the same habits that have helped you to be successful on a paper-based test here on this computer-based test. And yes, Kinsey, all of our tests work exactly like the real test. And then we also, for our Kaplan students, we provide every single thing that AAMC has released. And as they release something, we put it right into your account as well so that you're constantly being updated. But yeah, we definitely employ those. And I mean, I'll never tell you something that you should do that we don't also have, because all my coaching has been at Kaplan. So all of my tips and advice and questions and work that I've done with students was with Kaplan stuff. So yeah, absolutely. Absolutely. But that's what I've got in coaching today. I want you to really think critically about how you can take some of those bad habits that we've all kind of committed at least a time or two, and how you can build good habits for yourself, because you can replace the bad habits. You can make that go away, but you got to get a lot of practice, and you got to know what type of practice will take it away, because just taking full length tests over and over again, that's not going to do it, because you've got an amount of anxiety and you're not sure how to use the test. And so it's just going to overwhelm you. I would start with individual questions, clock ticking down, and move from there. And then get your strategy really fine-tuned, and then your full-length test, and then you're trying your CBT tools and getting used to all of that. So not jumping right into full lengths, but eventually getting to full lengths. Brianna, Kaplan provides the double AMC bundle. Yeah, we do. We provide every single thing that AMC has released. We also provide every single thing that Kaplan has released for the MCAT, as well as books that we don't release commercially. And so one thing that students don't realize is that our 7 series books, those are our content review books. And what you've seen from our class is that Kaplan courses is about are about combining science content with strategy, with efficiency and test taking skills. And so our lesson book is actually not available commercially. You can only get it through the Kaplan course, but we do include every single thing from Kaplan for the MCAT and everything that AMC has released and everything they will. We commit to giving you everything they will so that you don't have to do any outside investment. It's just all in one. I like to say it's an all-inclusive vacation to MCAT world. What else have we got? I know you have questions. We got 5 minutes. I can answer a lot of questions in 5 minutes. We can do it. What have y'all got for me? What have y'all got for me? You know what? I'm going to start talking about the MCAT channel since all the rest of our lessons. This lesson we had today is a sample from an actual Kaplan class. It's from the very first Kaplan class, which is Chem Phys. But all of the rest of the lessons except the boot camp this week are from our MCAT channel. So MCAT channel is our most unique feature. We actually have more live instruction for the MCAT than any other prep course out there. And it's because of our MCAT channel. So here, we're always customizing for you, whether you have a plus coach or not, but even more if you have a plus coach. And we look at your test results and your performance, and we figure out what your course schedule should be. Should you take advanced this or beginner that? And the way that we do that is with the MCAT channel. So all the lessons this week are going to be from the MCAT channel. They're going to be lessons that a student, like electives, that a student may take if they're ready. They may not take if they don't need it. So really interesting for us that way too. Are the practice tests in the bundles that we purchased? Do you mean that the Kaplan practice packs? I'm not sure exactly what you mean, Bob. You're so welcome, Brianna. Do you recommend taking the MCAT more than once to max? I do not, Jamie. I do not. And I talked about this yesterday too. 73% of the people who are accepted to medical school are first-time test takers. And so you really want to be a first-time test taker. You want to blow it out of the park. If you end up having to take it a second time, or if you plan to take it a second time, because some people just make this their plan. First of all, if you're a junior, or if you don't want another gap year, what's going to happen if you end up planning to take it twice, likely is that you're aiming for spring and you're going to end up taking it in summer. And that really decreases your chance by a lot. And then if you're like, well, I'll just see how this goes, and I'll take it a second time. Well, guess what? Only 27% of the people accepted to medical school are on a multiple attempt at the MCAT. So that's a really scary number. I don't want to be aiming for the 27%. I want to be aiming for the 73%. So I'm going to work as hard as I can the first time. That said, if you're not on your first time, the 27% of the MCAT students are multiple test takers. So you have a chance, but what you need to do is show a significant score increase. You need to show there's some real change, some reason for them to look at you again. A couple points is not going to do it. Not going to do it. Unless you were like scoring really high and you were just like right under the bar, it's just not going to do it. And so in order to get a significant change, what you're going to have to do is significantly change your prep methods. And you probably studied alone, or you studied with not a lot of resources. And now you're going to have to get a lot of resources because you need to make a significant change to get a significant score increase. But guess what? If you had just gotten all those resources to begin with, you could have been aiming for the 73%. So yeah, I say aim to do it once and work as hard as you can. And if you have to push back your test date from January until spring, if you have to get more resources, do whatever you can, because you want to be in that 73%. And I want to say something too, just about Kaplan generally, because I did get some emails about how can I afford Kaplan or whatever. I want you to know that Kaplan works with all kinds of situations. Not a lot of people know this about us. So we actually work with disabled veterans to fully comp the price of their courses through the Department of Veterans Affairs. We work with traditional veterans and their spouses and children of veterans to get discounts. We actually work with a lot of universities too. If anyone is from Howard University, we work a lot with Howard University, and their students get up to 60% off of our courses. So we have different relationships with various universities for different amounts so that their students can take Kaplan courses. And we also work with the FAFSA. So if you're on financial aid in undergrad, or you're a very recent graduate and you still have your FAFSA information, we use that for financial aid just like the schools do, except this financial aid you don't have to pay back. It's just covered for you by Kaplan. So I want you to know, if you think I want Kaplan, but I'm not sure I can afford it, don't assume, just at least find out. And we have the link up above, Kaplan Teacher Consult, that you can book me, me. You can always go there and set up a totally free consultation with a teacher, an actual teacher, to just ask them about what might be available to you. So really think about aiming for the first time and doing the best that you can, because that's your highest chance. That is your highest chance. And not that you can't do it on a multiple attempt, but you just gonna have to work even harder. Even harder. Let me see what else you got. Let me see what else you got. Kinsey, do you recommend taking notes from the Kaplan review books or just reading them? You know, I recommend taking notes on things that you don't know, but really what I recommend the most is finding out how much you know about that content anyway. I don't think anyone needs to read all of those books from front to end. I don't think so, because those are content review books. If you already know that material, you should not be wasting time reading that. So one of the things that Kaplan does, not only do we start our students with a diagnostic test, we follow that with a science content knowledge test so that we can figure out how much content you know, how much content you don't know, and how much you need to use those books and those science review videos in order to get caught up. Because our class does work with in-format MCAT questions. So we're assuming a certain level of knowledge, but we do that science review test in order to figure out how do we boost it up and how much are you missing and what are you missing? Because you should never be studying. You don't have time. 300 to 350 hours is the average that people will spend studying for this test. And that's on top of following and shadowing and your internships and your volunteer work and sometimes your class, like all of these things that you're doing in your life. And now you need 300 to 350 hours average. On top of that, you cannot study something you don't need. So one, you should take notes, but only on stuff you don't know. Two, you should really figure out what it is that you know and you don't know so that you're not reading chapters on stuff that you already know, because nobody has time for that. Nobody. What else have we got? Trevor, you just bought the 7 series book. Do you still get access to that? No. Unfortunately, the 7 series book, it comes with our Kaplan courses. They all come with our Kaplan courses. But they don't make you a full-on Kaplan student. You'd have to enroll in a Kaplan course in order to get all of our practice tests and our lessons and our classes and our teachers and all that stuff, and including the AMC resources. However, I do want to say something about the 7 series, because I know a lot of you have it. It's highest rated on Amazon. We love it. We're very proud of those books, and they are given to every single one of our Kaplan students. I want you to know that if you're like, hey, I bought those books, and I know they're included with Kaplan, and I'm like, I don't want to pay for them twice. We don't want you to pay for them twice either. So call 1-800-CAP-TEST if you're going to enroll in Kaplan, and just let them know that you already have those books, and they will take some money off your course in order to make up for that. So if any of you are out there and have wondered or worried about that, no worries. They'll fix it for you. They'll fix it for you. Let's see what else we got. When is the best time to take the MCAT for the first time? Well, we want to do the first time whenever possible. I really like a March test date. I really like early spring. If you're a junior, because a lot of people don't want to take gap years, and so you want to get it out of the way, and then you can start applying first thing when applications open up. You don't have to wait. I was saying March too, because you are probably not coming up on any finals in your semester, and so you know you might have like slowed down your prep a little bit coming at finals in the fall. But there in the spring, in the early spring, you don't have any finals, so you probably could spend more time on the MCAT and really focus more. So I really, really like that time. And that way, if you do need to take it a second time, which you should not plan for, don't make that your plan. But if you do end up, unfortunately, having to take it a multiple time, then you can take it in late spring and still be there for the beginning of the application season. And so I really like that early spring. And I do think that right now for January, for most students, it's late to be starting for January. Not to say that you can't be successful, but it's a little bit late, so you might want to have more time. More time. I mean, what else have you got? Well, Alyssa, you know that double AMC, I'm going to talk about this in our boot camp too. I'm going to have a lot of stats. They don't really go into a lot of detail about what's going on. I think that the schools do show a little preference for first timers, because if you're a second timer, like I said, or a multiple timer, you have to make a significant difference for them to relook at you. So if you only get like a point or two, they're not going to really be like, oh, that's super significant. She's really changed. We should change our mind. Like maybe something happened the first time. Maybe she was sick, or maybe, you know, family situation, but she's obviously worked hard and really changed. And now we have this much higher score. And I believe that she'll be successful. Because if it's only a little bit, they don't. So, I mean, in that kind of way, yeah, they kind of do show preference to first timers. And then, you know, I think too that sometimes people give up. I have seen more people like burn out and give up on themselves, you know, because because my role is the free to the public teacher. So I see a lot more students who are not prepping within a course, and I see a lot of them kind of burn out and give up along the way. So that does happen. But I don't think you should ever give up. As much as I say I don't think you should plan for a multiple attempt, I don't believe that you can't be that person. And I think that if this is your goal and it's your dream and it's something you want and you don't get it the first time, then yeah, you should keep going. You should significantly change your prep methods and make sure that you're getting what you need. But that said, you shouldn't aim to have to take it more than once. But if you don't make it the first time and it is your goal and your dream and you're for sure that this is for you, then yeah, I think you should keep prepping. But don't make that your plan that you're going to take it twice. Some people will say to me, I'm just going to take it once and see how it goes, and I'll take it a second time. That's not a great plan. Remember how competitive this process is. All right, guys. I went over again. I'm always going over. You've got my email. But before I leave, can I ask you just one thing? Can you just all tell me something that you learned today that you maybe didn't know before that you're going to employ on test day? I just make a teacher's dream come true. Make my day. Don't let me sit here and think that nobody learned from us today. I know you must have learned something. I learned that teacher Ashwarya may have better science pun skills than I do. I'm not gonna tell her to her face, so y'all shouldn't tell her. I'm sure she's not listening to me. She hears my voice too much. But okay, all right. If y'all didn't learn anything today, I'm gonna go home and cry into my pillow. But we'll try again tomorrow. And does anybody know what tomorrow's topic is? Does anybody know what tomorrow's topic is? Is anyone signed up for tomorrow? I hope you are. Tomorrow's topic is the kidney. The kidney. Thank you, Jessica. Thank you for not leaving me hanging there. Oh, there you are. Oh, I guess I must be on a larger delay than I thought. I was like, oh my gosh, y'all left me hanging. You didn't learn anything. Good. Don't always jump to the math. Oh my God, Alex, I love that. I love that because that's a red herring a lot of times. They're going to assume, because what did you get all your points for when you were coming up in math all throughout school? You didn't get your points for a right answer because you had to show your work. You couldn't just give the answer. You had to do both. And so your instinct is jump straight into math. But sometimes you don't have to. And they're looking to see who is clever enough to realize that you don't have to jump straight into that math and who is going to get stuck on the speed bump by doing all of this math. And yes, tomorrow is the kidney. I know that you guys worry about the kidney. And so I made sure that we have it very early. And this is a channel lesson. So this is a lesson that would not be assigned to everyone. We let you go to any lesson you want, of course. But we also make recommendations based on your strengths and weaknesses and where you're at in your prep process. So it won't necessarily be recommended to everyone, but I'm going to send out a homework quiz. Make sure that your email is in my poll, because if your email's not in there, you won't get it. And it will be a good preview for what we'll be doing. And then we go. I'm glad that y'all learned a lot. I can't wait to see you. I love to end on the same note, so I'm going to do it again. I can't help myself. And I just want to thank you so much for coming. Honestly, I went to school on full scholarship, and I had to have a conversation where I sat my mama down and told her, hey, guess what? I've decided I want to be a teacher for the rest of my life. And everybody was like, wait, what? Especially my mom. My mama was especially worried about that decision, but it's because it's my dream. This is my happy place. And I tell you that because I want you to know that I honestly am really humbled by your decision to allow us to help you. I get to live my dream by helping you to reach your dreams. I've never had a student who scored an increase, and so this is my happy place. I love it here. And that is what you are doing for me and for all of us here. You're allowing us to live our dream by helping you to reach yours. And I can't think of a better place to be or better people to help or work with. So just thank you so much for choosing us, for allowing us to help you this week and in the future, and for trusting us. This is a very scary decision in your life. It's a scary, hard time. And we're just so humbled by the fact that you chose us. So thank you so much. I can't wait to see you on tomorrow for the kidney. If you can't be there for the kidney, make sure to sign up for the other stuff in the week. Even if you can't do any in the week, guess what? We got stuff on the weekend. We got the boot camp. I hope to see you there. And if nothing else, go ahead and send me an email. I'm happy to advise you as best I can. See you soon. Bye-bye.